In this video we're going to look at erosion and sediment control. So the erosion processes, when we remove topsoil and grass off a clay or a sandy area, we expose that area to rain. Um, when the topsoil and grass is on it, then the grass acts like an umbrella, if you like. It sort of takes the force of the raindrops, and the roots of the grass or the shrubs or the bush that's there hold the soil together, the topsoil together. So you don't get much erosion of topsoil or vegetated topsoil when it's raining. However, when you remove that protection, the clay that is exposed, or clay or sand, will erode. What happens is the raindrops come down, they hit the bare clay, the bare soil, and they dislodge just a few grains. But there's billions of raindrops in a rainstorm, and so they dislodge these soil particles, and the soil particles get carried with the runoff down to streams when it sort of gets into the stream. Now in the stream it settles to the bottom. It gets deposited in the stream. It settles to the bottom and can smother the benthic organisms that live in the bottom and the sides of the stream. Now they are the root of the ecosystem, of a stream ecosystem. So they're the little bugs that get fed on by bigger bugs, that get fed on by bigger bugs, that get fed on by fish, and so on right up the ecosystem. So by smothering those organisms on the floor and the sides of a stream, you are taking out the bottom level of an ecosystem, and obviously everything above that gradually doesn't have anything to eat and starves. So it can do quite a lot of damage to natural waterways, which is why it's so important for us engineers to consider to take whatever steps we can do to sort of try to prevent that or to minimize it. So let's get some definitions. So sediment is the soil particles arose from exposed ground that is carried to natural water systems by runoff. Okay, so and then it settles down to the bottom. So there's the sediment, the suspended load, and then gradually it settles down to the bottom and becomes the bed load where it gets pushed along. Erosion is the soil particles are detached from in situ soil by rain or wind. So you need to consider wind as an erosive force as well. Natural water systems, we're talking about streams, lakes, and oceans. Runoff is the rainwater that flows downhill over the ground surface. So how does that happen? The different types of erosion. As I said, the raindrops come down, they hit the bare soil, they remove a couple of soil particles and they erode down. But there's also, so that's splash erosion. But then the water, as it's flowing downhill, starts forming into streams, and those streams have velocity, and they can erode more. They can create more erosion. So initially it flows across the land as a sheet, so they've got sheet erosion. Then it comes together into little channels, rills and gullies, and they concentrate the water flow and they concentrate the force. So therefore the erosion in those those little rills and gullies is more, because there's more force to dislodge the soil particles. And then they all come together into a gully, stream, and they get into the stream. Once again, the stream will actually see more flow than it would have otherwise. When this was covered in topsoil, most of the moisture would have taken, the water would have taken a long time to soak in through the topsoil and then gradually made its way down to the stream. So a storm comes over, drops a whole lot of rain, and it would have taken a long time for those raindrops to actually make their way down to the stream, so the stream flow wouldn't have changed all that much. However, when you remove that topsoil and grass, there's no buffering happening. The water hits the soil surface and then flows straight down into the stream. So the stream sees a much higher peak in flow than it would have otherwise. And so once again, the stream will be flowing with more water, therefore it's flowing faster, therefore it's got more force, therefore it causes more erosion of the stream banks and the bed. So once again, you're doing some more damage to it there. In addition to that, the soil, when it's exposed, can actually get much wetter than it would have otherwise, and it gets heavier, and therefore if it was marginally stable, making it heavier by adding water to it, means that it's more likely to slump or slip. So you can get earth slips and erosion. And once again, once that's slipped, you've got a hold of loose soil which will get washed away and will come down into the stream with debris flows. So you can see there's a whole lot of mechanisms all acting together. They all result in erosion, either of the land or in the stream, and it's something that needs to be addressed. So the factors that would affect the degree of the erosion come down to climate, so the rain intensity. So tropical rainstorms drop a lot of water in a very short period of time, so it's much higher intensity. And with climate change, storms in Auckland and New Zealand are becoming more tropical, so we're getting much heavier rainfalls. Soil characteristics, the texture, clays will hold together better than sands, for example. If there's organic matter in there, it will sort of tend to hold it all together. The soil permeability, if the water soaks into the soil, then it's not flowing across it, and it's going to have less erosive force. And the soil structure, how strong is it held together? The topography, that's the slope of the land. So a steeper slope obviously allows the water to flow higher velocity. A higher velocity is more energy. More energy means that it can erode more. If there's ground cover, then that ground cover will take some of the force off those raindrops and will lessen the erosion. So as we see later on, we mulch, we put coverings over the top of it to try to protect it. The duration of the exposure, that is how long it's exposed for. Obviously, if it's exposed for a longer period of time, there's going to be more erosion off the land. The other thing that's not there is the area that's eroded. So if you expose, if you have a 5 hectare job and you expose it all at once, then you're going to have more erosion than if you'd broken it into two parts, just done 2.5 hectares, and then covered it up and then did another 2.5 hectares. So the more area you open up, the more erosion obviously is going to happen. And evapotranspiration, that is, if some of the rain that falls evaporates back into the air, it's not flowing across the ground and it's not causing erosion. So why are we doing this? Well, first of all, it adversely affects water quality. As I mentioned before, this the water quality, it can sort of take up oxygen in the water, and it can cause all sorts of problems there. As I said before, it can also smother the little plants and animals in the stream. The clay can get into fish's gills, for example. It can suffocate them, or it can get down onto the floor and smother those benthic organisms, which are the root of the stream ecosystem. And they also can cause effects to the estuaries and the coast as well once it gets out there. So it's not just restricted to the streams that flows into. The streams flow into oceans, into seas, and it can affect those, especially estuaries. And can change the food sources and life cycles. As I mentioned, you take out the bottom level of an ecosystem and you are causing serious damage to everything above it as well.